Dear students, this is Praveen KM. In today's episode, let us discuss some of the very important concepts and questions based on three very important chapters. They are gravitation, oscillations, and waves. Let us take up gravitation. To start with, I'll go to Newton's universal law of gravitation, which states that the force of attraction is equal to F is equal to G into m1 into m2 divided by r square, where r is the distance between the two masses m1 and m2, and capital G is universal gravitational constant, whose value is 6.67 into 10 power minus 11 Newton meter square per kg square. Then we also get acceleration due to gravity expression, that is small g is given by gm divided by r square. From this we get a very vital relation, which is gm is equal to gr square. Small g can also be written in terms of density of earth by replacing mass by volume into density. So we get the expression for small g as 4 by 3 pi r into rho into g. Then about variation of small g with height and with depth. As we go above and above the earth's surface, value of g changes according to the expression g dash is equal to gm divided by r plus h whole square. But if the height is very less when compared to the radius of earth, then this expression can also be written as g dash is equal to g into 1 minus 2h by r. Similarly, with the depth, the value of g changes according to the expression g dash is equal to g into 1 minus d by r. So from these two expressions, it is evident that as we go higher above the earth's surface, the value of g decreases. The value of g changes with lambda according to the expression g dash is equal to g minus omega square r into cos square lambda. Lambda can be understood using this diagram. If this is earth and if this is equatorial axis and if this is polar axis, if this is the location of interest, then from the center of earth you draw an imaginary line which makes an angle lambda with equatorial axis. So the value of lambda at equator, as you can see from the diagram, is 0 degree. So what happens to the value of g at equator? G dash becomes g minus omega square into r. But at poles, lambda is 90 degree. So from which we get an expression for g dash as just g, because cos 90 is 0. So from these two expressions, it is clearly evident that the value of g is maximum at the poles and minimum at the equator. And we also should know that this equatorial radius is greater than this polar radius by 21 kilometers. This also explains that the value of g is greater in poles than in equator. Dear students, let me explain few more concepts on gravitation. I want you to note down these expressions. The orbital velocity of a satellite is given by the expression Vo is equal to root of gm divided by r plus h. If h is very small, then Vo can be written as root of gr. Then the escape velocity of a satellite is given by the expression Ve is equal to root of 2gr. Escape velocity is related to orbital velocity by the expression Ve is equal to root 2 times Vo. The time period of a satellite is given by the expression t is equal to 2 pi into root of r plus h whole cube divided by gm. Again, if h is small, this can be written as t is equal to 2 pi into root of r by g. Then let's have a look at Kepler's laws. There are three laws of Kepler. The first law states that every planet revolves around sun in elliptical orbits, with sun being at one of the foci. Then the second law states that the imaginary line joining the planet to the sun sweeps out equal areas in equal intervals of time. The third law given by Kepler says that the square of the time period of any planet is directly proportional to the cube of the semi-major axis. Then we'll have to discuss about gravitational potential. Gravitational potential at any point is given by the expression V is equal to minus Gm by R. Similarly, gravitational potential energy of any mass at any point due to Earth is given by the expression U is equal to minus G into m into small m divided by R, where R is the distance of these points from the center of the Earth in both these expressions. In most of the cases, we write small r as capital R plus h, where h is the height of the point from the surface of the Earth. Then the time period of geostationary satellite is 24 hours and its height above the surface of Earth is approximately 36,000 kilometers. Now let us take up some of the problems from the chapter Gravitation. The problem is like this. Two metallic spheres, each of mass m, are suspended by two strings, each of length L. The distance between the upper ends of the strings is L. The angle which the strings will make with the vertical due to mutual force of attraction is options A. Tan inverse of Gm by Gl, B. Tan inverse of Gm by 2Gl, C. Tan inverse of Gm by Gl square, and D. Tan inverse of 2Gm divided by G square L square. Dear students, in this problem, the two masses are hung using two strings and the distance between the two masses is capital L. These two masses, due to force of attraction, they come closer, and due to which the orientation of the string changes, and in the new orientation, the string makes an angle theta with the vertical. But still, even in this orientation, the mass will be in equilibrium. What is equilibrium? The net force acting on the mass is 0. Using diagram, let me show the new orientation and as well as the old orientation. This was how initially the two masses were hung. Later on, due to force of attraction, they come closer, due to which the new orientation will be like this. And as you can see in the diagram itself, this new orientation makes an angle theta with the vertical. And the condition for equilibrium says that the net force on this is 0. And how many forces are acting on each mass now? Obviously, the weight of this mass, which is mg in the downward direction, and the tension in this direction. This is T. Of course, the force of gravity, gravitational force in this direction. So let me call this as F. Now, to write the condition for equilibrium, we'll have to show that the net force acting on this is 0. Now, these two forces, that is the weight of the body, is balanced by one of the components of tension, whereas the gravitational force is balanced by another component of tension. Here the idea is to resolve this tension into two components. One of the component is vertically upwards, the other component is along horizontal. This upward component will balance the weight, whereas the horizontal component will balance the force of gravitation, the mutual force of gravitation. Let me write it mathematically. And students should note that if this is theta, this will be theta again. And since this is theta, the upward component is t cos theta, whereas the horizontal component is t sin theta. So what is t cos theta trying to make? T cos theta is balancing the weight of the body, whereas t sin theta is balancing the gravitational force. This is t sin theta, whereas this is t cos theta. Let me write it mathematically. that is T sin theta is F, that is equal to G into M divided by L square, and T cos theta is weight, that is mg. Now, if I take the ratio, I'll get tan theta. Why should I take the ratio? Look at all the four options. They are expressed in terms of tan theta. Therefore, if I take the ratio, I'll get T sin theta by T cos theta, which is tan theta, that's equal to gm square by L square divided by mg. So that gives tan theta is equal to, m gets cancelled, gm by gl square. And theta is tan inverse of gm by gl square. So option C is right answer. But dear students, you need not do so much for this problem. Just by looking at the four options, you can eliminate some of the options, or in other words, straight away you can write the correct answer just by using the concepts of dimensions. Students are hereby advised to have a look at all the four options in all the given questions in any competitive exams, because just the concepts of units and dimensions will certainly help you, at least in few problems, to eliminate the wrong answer or to pick the correct answer straight away even without solving the problem. And this is one such example. Look at that. All the four options consist of tan inverse of something. That is, that something should be a number having no unit and dimension. So what does that make? The quantity inside the bracket should not have any dimensions. But we know that the quantity in the numerator, gm is gr square. Gm is gr square. So what if I substitute gr square in all the four options? In which options do I get a unitless, dimensionless quantity inside bracket? Let's have a look at each options. This is gr square by gl. I get length in numerator, impossible. Again, gr square by gl. Again, I get length in numerator. Gr square by gl square. This satisfies my condition. No units. Gr square by gl square. No length, nothing inside bracket. And gr square by g square l square. There is g in denominator, which also clearly says that option C must be the correct answer, since the quantity inside bracket only in C doesn't contain any units or dimension. So students can use this as a shortcut. Now let's move on to the next question.